Tonight is July the 1st, 2016. This is my final update before I actually finish this beauty. It's turning out really nice. I'm going to be very pleased with it. I have one channel completed, and I've been testing it, and it'll do a 30 very good watts. It's actually more than I expected. There's a lot to be said about it. I'll show you how it performs. I've got every component in there properly mounted and soldered and everything except for one, and that is just 350 ohm cathode resistor, which I have strung out here. I know this is ridiculous, but this is the only way I can get 350 ohms. I've ordered some 350 ohm 10 watt resistors, but this is my cathode resistor for the time being, and it works fine. So I've got the left channel finished, pair of 5881s. I've got two 6SN7s in it right now. This is supposed to be a 6SL7. I've known this for a long time, and that is the amplifiers of this era, the 1955 to 60 era time frame, they had a few gremlins in them, and this one did too. And I had to change two components in it to just make it work right. It was unstable. I don't know what else to call it, but I improved it greatly by changing the negative feedback, and I had to change the input capacitance and resistor, and it improved it immensely. Let me show you some things here. Let's start by looking at the schematic. Here's the schematic of it. You can find this online. All you have to do is Google Acrosound transformer. Acrosound transformer catalog will pop up. This is one ultra linear 6L6 circuit using the TO-300 transformer. I'm using the TO-305, which is this transformer right here, but the one I'm using just has two extra 500 ohm secondaries, which I don't use. They're just taped off. I'm going to show you underneath the amp. This feedback circuit right here just doesn't work very well, so I've changed that from 5.6K to 6.8K, and I changed the feedback capacitor from 120 picofarads to 450. Also, I don't have it drawn in here, but I changed this to 100K instead of 470K and a 0.1, and I get much better response out of it. The 0.05 and the 470K as they have it will work, and it is stable, but the low frequency response is horrible. Now if you go above about a 0.1 here, then it starts becoming unstable. So, but everything else is the same. The values of all these components, the phase relationship, everything about it is right. It works. Now let me show you something that's almost the duplicate amp. See, a 6SL7 is a high mu triode. 6SN7 is a medium mu. Now let's go over to this little Fisher amp of the same era. They use a 12AT7, 12AU7, 5881s. Even the same component values, 350 ohm resistor in the cathode circuit. A lot of the components are either the same or very close. Now this one is pretty special. It has an extra winding right here on the output transformer for the cathodes, and that was a pretty big deal back in those days. McIntosh does that too, and their transformers made a huge difference. But this amplifier and this amplifier are virtually the same thing. They both have their gremlins. I'll show you some of them, but I think I've tamed it pretty well. So let's get to looking at it here. I've got everything set up, so I hope you can you can see what all's going on pretty much at the same time. I'll put the camera on a tripod here in just a second. We got it hooked up to this 8-ohm load down here. Got lots of power dissipating ability there. Got my mascot out here with me to protect me, Max the cat, and we'll be, of course, we'll watch its power, its distortion, etc. You know how all this works. So let me get it hooked up, get it to producing some output, and we'll see how it goes. Then I'll flip it upside down so you can see underneath it also. Okay, we'll start out by driving it at 2 kilohertz. The reason I use 2 kilohertz here is because that allows me to quickly go between 2 kilohertz, 20 kilohertz, 200, and 20. Well, right there it is. There's one nice measurement. 29 watts at a 0.4% THD. Doing pretty good, huh? The input voltage, I try to make it exactly 120. That's important. I made a video some time back about how dropping the voltage down to 110 changes things dramatically. Here's its output from the monitor ports of the AA501. This is just a monitor port. This is its error signal. Of course, we can turn that down to whatever level we want. And there's just a nice sine wave of it. At 2 kilohertz, okay, that also, importantly, is driving it at 0 dBm. So that's 0.776 volts driving it. Right here, if you look up 0 dBm, coming out of here, this is set for 0. 0 dBm drives it to 28 watts at 0.4% distortion. Now, when I uncal this thing, we can raise it. We can raise it a lot, as a matter of fact. If we watch this, we'll raise it to 1%. There it is, that's 1%. And it's doing 31 watts. So it's a 30-watt amplifier. It's a beautiful 30-watt amplifier. Does a magnificent job. That's at 20. I'm gonna run it down to 25 watts, and that's seems to be a really nice place to test it. There it is, about 25 watts, 0.3%. Now we'll go from 2 kilohertz to 20 kilohertz. And we still get 22 watts. I haven't done the ratios yet. That'd be 10 times the log of those power ratios would be its dB loss at 2.7% THD. And there's our almost 2000 hertz. Here is what it looks like. And there's our error. See, it looks pretty good. We're not quite at clipping. You can see a little bit that misshapen. It's not the perfect sine wave anymore. But it's not bad. And what I've noticed about all of these amplifiers, again, of this era, is that their high frequency response is less than perfect, but this is not bad for 20K. Just not bad at all. Okay, let's go to 200 hertz, and I'm not changing anything else. At 200 hertz, it goes back to 25 watts, 0.357. See, there's our 200 hertz. Things doing pretty darn good. And then we're just going to go for broke and go to 20 hertz. We got to get this thing to sink in again. Sometimes it wants to flounder a little bit. That's not what we want. Hopefully we can get it to settle down. If we can't, that's okay. We can look at it down here. There's our 20 hertz. Looks pretty good, huh? And at 20 hertz, it's dropped to 12.5. So that's about half. So that's about a minus 3 dB, but it's still at only 0.3%. If we crank this thing up to 1%, which is kind of a good benchmark. We crank this guy up. Let's see if you can watch both of them at the same time. See, our power's going up. Takes a little bit more to drive it, of course. So all of a sudden we pass it. It's easy to. There it is. There's one at 20 watts. 20 hertz. Okay, you really want to know what it can do? Let's go to 10 hertz. There's 10. See? 10. It's kind of confused, but it's trying. There's 10. There's its THD 3% at 7 watts, but 10 hertz. I mean, give me a break. That's nobody rates their stuff down there. So it's actually doing quite well. Some comments here. These labels right here, I printed on a metallic type of paper, and then I glued them on. So that's how come that looks so nice. And there. I've got to finish this side right here. I'm really pleased with it. I think it's going to sound great. I have not heard it yet, and I've still got to get in this resistor. I mean, I got to obviously get rid of that. But let me flip it over and I'll show you underneath it. Okay, well, I don't know. Let's see, I'm using some, I still got it on. Maybe that's not a good idea. I'm using some vintage capacitors over there. Those 0.1s, those are Black Beauties as they're known. Another thing that I changed in it is when I said I changed that 470K to 100K, these are 100K pots. So that's what it does. I've actually got that 470K installed right there, but I can leave it or remove it. It doesn't make any difference. Here is all of those. The audio flow is from this to here, and then to the output tubes. Power supplies down here. Built it all in one place. I put diodes in series. I shunted them with 3 megohm resistors. That helps equalize the voltage across the diodes. These are the same. These are the correct values that Acrosound had in their schematics. One of the things I found out about this hum balance pot right there is that it actually worked better to ground than it did to back to the cathode circuit. I wish I could show you all of the details. They're just beautiful. I really enjoy this. You know how it pans out over here. Let's see if we can make this thing work. What are we running at? 20 hertz. Oh yeah, well we have to change the bin rate. Let's go up to something reasonable like 2 kilohertz. Well, we're overdriving it a little bit. Let's go back to 0 dBm. And there's our 20 kilohertz right there. See, this thing says it's 0.4%. Same thing as the Tektronix. I've got the 60 hertz to 120 hertz down here at almost 100 dB down. The signal to noise ratio, I can't show you all these because it just takes too much time. Signal to noise ratio, the signal to noise ratio is 83 dB. I'm very pleased with that. So it's really doing quite well. I'm not recommending everybody go out and build one of these things, but I think it's going to be nice. I will play some music through it, so those that want to hear music can. I have the parts, except for these 350 ohm resistors that are coming in hopefully soon. Here's the insulation. So I ran a shielded wire from the inputs over to the second stage, so I've got to build this stage. This stage will look just like that. These components right here have to go over here. Had a heck of a time getting the colors right on these transformer leads because they're just so faded it's just impossible to read them, except for this one. This one right here, which is not hooked up yet, has the right color. I can actually read the colors very clearly on it, and I had to make very, very careful ohm resistance readings between the screen and the plate, and the screen and the plate, and the center tap, and all that kind of stuff to determine the color code over here, because It was the devil to figure out. Let's see, here's the back of it. So here's the output. It's pretty traditional for that era. These types of, got a slide on off. This is of course modern, fuse, and the other channel, this is be the left and right channel. So there it is. I'm using a 7 Henry 150 milliamp choke in there. I think what I'm going to do at the end of this, and at the end of the video when I get the stereo part working, is actually compare it to other amplifiers of that time frame, and then the ones that came right after it. See, this one right here is of that time frame, and it performs very similar. Actually, this one does slightly better, just slightly better. And then came along the Dynaco stuff, like the Dynaco Mark III, got a little bit better. You know, also around that era, McIntosh came in there around the late 50s, 59, 60 time frame with their design, and theirs outdid everybody's because of their transformer for one thing, and their design. So there it is. Here's the my last update until I finish this beauty, and you know, get the labels on it and do the best I can to make it as pretty as I can. And I think I'm going to be really pleased with it. I'm very pleased that the signal to noise ratio is way down there at -93, because I'm going to put this thing in my house and swap out that big solid state Mac that I use in there. And I use clip horns, so they're really sensitive, and I don't like hum. So I don't think there's anything else I can show you right now. Here it is, still running 28 watts at 0.475 at 2K. And you know, if you want to see it at 1, which is a traditional thing, we'll run this guy down to kilohertz, 1002 hertz, 28 watts still at 0.46. You know, it's got to do it all, and it actually does pretty darn good. So the design is good. Like I say, it really did have some gremlins in it until I had to change out. Okay, Miss Kitty. Until I had to change out. I really had to work hard on this. And the way I did it is the way that, if you've watched many of my videos, I did it by using the I know it's kind of dark in here. I can turn on the lights now, but the lights present so much glare. I use a resistor decade box here, and then I use this variable capacitor right here, and I can dial it right in. Of course, you got to check it at low and high frequencies. You can't just dial it in at 1 and think that it's going to work for everything, because it doesn't work that way. So thanks guys for all your suggestions, for watching, for commenting, and I hope you enjoy this. This is probably the last amplifier I'm going to build. I've built a lot of amplifiers, but building this stereo version has actually been a lot of work, and I just don't see any reason to build more after this. I love to build RF amplifiers. I'll probably build some more of those, but we'll see. Yeah, see, my voltage has dropped to 118 volts. So it's, you've got to establish a point that whatever you're going to measure it at, because if you measure it at 110 volts, you'll get completely different readings. So you got to remember that when you measure your own equipment, and if it doesn't perform the way that you think it should and you're scratching your head, make sure your input voltage is up to specs. There you go. Thanks a lot.